On this mission, we will learn how to do a cold start on the aerospatial Airbus SA342 Gazelle, based on the procedures of the real aircraft, but adapted for DCS. You can choose to do the training on the Gazelle L, M, or minigun variants, but the procedure is the same for all three. The cold start procedure includes the following sections. Internal checks, before starting the engine and spinning the rotor. After engine start checks, enable navigation, radios, and defensive systems. This training series is set on the Sinai map, and the approximate mission time is 20 minutes. If the yellow crosshair cursor disappears from view, bring it back by pressing left Alt+C. This instructor's volume level can be adjusted with the helmet sound slider on the DCS options audio screen, which you can access by pressing the escape key. Also, you can press spacebar to skip long voiceovers. By default, the Gazelle's animated crew bodies are not shown, but you can press right Shift+P to alternate between showing only the co-pilot, only the pilot, both pilot and co-pilot, or showing neither. You can take the seat of any crew member, using the keys 1 for the pilot, 2 for the co-pilot, and 3 for the gunner, the latter only on the Gazelle minigun variant. Try these keys and then press spacebar to continue. This mission begins just after you've completed the Gazelle's exterior checks and entered the cabin. It's dark, but fortunately the Gazelle has a couple of interior lights that are wired directly to the battery, and works even without the battery being connected to the battery bus. One is the roof lamp. You turn it on by rotating its rear ring, which also adjusts its brightness. Try it now. There is a switch just beside the lamp, with 2 positions. Normal allows the user to set its brightness as we just did. Attenuated sets the lamp to minimum intensity, for night use. The lamp's frontal lens allows you to select the light's color, red or white. Adjust the roof lamp as desired, and then press spacebar to continue. The other interior lighting that can be used at this stage is the ultraviolet lighting, composed by 2 UV lamps attached to the roof's front strut, which illuminate those instrument panel labels that react to the ultraviolet light. The highlighted knob turns the UV lights on, and adjusts their intensity. Try it now. You can also employ the night vision goggles that are attached to your helmet, as they have their own batteries. Turn them on with right Shift+H. Try it now. They take a couple of seconds before showing their image. You can reduce their brightness with right Alt plus right Shift+H, and increase it with right Control plus right Shift+H. As you can see, they are more suitable for looking outside the helicopter than looking at the instruments. Turn them off, to continue the training. Now that we can better see our way around the cockpit, let's proceed with the internal checks. Battery switch to on. The Gazelle's electric system comprises 2 sections, the DC and the AC systems. The DC system can get power from 3 sources, from a ground power unit, typically used for ground maintenance, but which can also be used for a faster cold start, by allowing the warming up and alignment of the navigation systems to be done in parallel with starting the engine. From a generator driven by the engine, which at the moment can't provide power since the jet engine hasn't started yet. And from a 24-volt, 40 amperes per hour battery, that this switch connects to the electric bus. The voltmeter automatically shows the DC voltage of the GPU, if there is one connected, of the generator, if active, and of the battery, if the generator is not yet active. The AC power is supplied by a 3-phase alternator driven by the engine, or by a ground power unit. Its nominal voltage is 115 and 200 volts, at 400 Hz. A 115 to 26 volt transformer feeds the single-phase 26 volt bus that powers some of the navigation equipment. Please note that the battery cannot power the AC bus. Check fuel. Read gauge to confirm the correct quantity has been filled. The Gazelle fuel is contained on a main 437-litre tank installed under the gearbox. An auxiliary 90-litre fuel tank is installed to increase range. For this mission we have both tanks full, but as you can see, the gauge shows only the main tank fuel level. The mark between 30 and 40 indicates the point at which the auxiliary fuel can begin to transfer into the main tank, 347 litres. Check clock. Wind and set. On DCS the clock is already winded and set to the current mission time. During the cold start, we will use its chronometer function to check the starting time uses. Exterior lights. Switch on and check. Navigation lights. Located on the fuselage roof and on the tail. Use the F-pose switch to select either blinking or steady mode. You can press F2 to check them on external view. Press F1 to return to cockpit view. Anti-collision light, located on top of the tail fin. Its switch offers two modes, normal for full intensity, attenuated allows you to use the adjacent knob to manually adjust its brightness. Landing light, set to on. Located on the front underside of the nose, it is operated with two controls on the collective lever. The switch rentrée sortie retracts or extends the landing light. The switch fair vario array turns the light on or off. While the switches are clickable, you may prefer to control them with your hoters, using the control bindings shown on the figure. Instrument panel lights. Set to on with the SGA switch. The PUP adjacent knob adjusts the brightness of the center console lighting, while the PBO knob adjusts the main dashboard lighting intensity. Front doors. Close both doors with right control plus C. Fuel flow control lever. Check it is closed at its rearmost position. In flight, the engine and rotor speeds are automatically stabilized by a governor, which controls the fuel flow amount as the rotor is able to absorb more or less power. This relieves the pilot from having to take care of the engine handling once normal speed is attained. The governor is in control of it. This lever controls the governor's fuel flow valve. Its rear position corresponds to the start and slow running settings. Its forward position corresponds to the normal flight position. Rotor brake. Release, by moving its brake lever forward with the mouse or with the home key. The rotor brake is actuated mechanically and controlled by this lever. Its forward position corresponds to brake off, while its rearmost position corresponds to brake on. Generator gene switch. Set to on. The generator works also as a starter engine for the helicopter's jet turbine. Once the turbine is running, it functions as a 28.5 volts, 135 amperes, DC generator. Alternator alt switch. Set to on, except if there is a ground power unit connected. It won't provide power until the main turbine is operating. The alternator provides three-phase AC power at 200 volts, 500 volts amperes, plus a step-down transformer to provide 26 volts AC, to power all the AC equipment of the helicopter. Attitude indicator, gyroscope compass, POP-3 missile panel, IFF, nadir navigation, radar altimeter, radar warning receiver and flare dispenser, and the stability augmentation system and autopilot. Flight controls travel. Check full travel of the flight controls by moving the cyclic stick, collective lever and rudder pedals. You may want to display the controls overlay, with right control plus enter, to check what movements DCS is interpreting. That's a good test. Press spacebar to continue. Cyclic control stick. Leave at center neutral position and set the magnetic brake switch to on, to prevent displacement of the cyclic stick under its own weight. Collective check. Make sure that the collective lever is at its full down position, to prevent the aircraft from trying to lift while the engine is being started. Warning lights panel. Test lights by press and holding its test button. The figure shows what each warning light means. Check other warning lights. Press and hold the test button to check all the lamps except the warning panels and the torque indicators. Barometric altimeter. Check it is set to the correct air pressure, as indicated on the briefing, which you can display with left Alt plus B. Its short needle shows thousands of meters, the long one shows hundreds of meters. The counter displays the air pressure, in hectopascals, and can be set with the highlighted knob. Torque indicator. Set index. The effective torque that the engine can safely apply to the rotor is limited by both the current altitude and the current air temperature. The index is used as a warning when the aircraft is near its torque limit. To determine what is our current torque limit, first check the airfield altitude in feet. You can get this value from the F10 map, but I can tell you that currently we are at 155 feet. Next, check the outside temperature on the highlighted gauge. You can also read the temperature at the bottom of the mission briefing. The current temperature should be 20 degrees Celsius. Armed with that information, consult the maximum allowable torque chart that is on top of the instruments panel. You should see that for an altitude of almost sea level and at 20 degrees Celsius, our maximum torque is in fact 100%. So, turn the knob by right-click and drag to set the torque index at 100. Not really a part of the procedure, but on DCS it is good practice to request air traffic control clearance to start our engines. We will use the UHF radio to contact ATC. Turn it on by turning its mode knob to any position beyond O. To have a better view of the radio, you may want to hide the collective by clicking on its base. The UHF visor will blink while the radio is warming up. Press spacebar once an audio beep is heard and the blinking has stopped. The ATC frequency at this airbase is 250.500 MHz, so use the radio's keypad to enter 250500 and then click the validation key to tune the frequency. Good, the UHF radio is now tuned to air traffic control's frequency. The Gazelle has 3 radios, and while all 3 can receive at the same time, you need to select which one you will use for transmit. On the pilot's intercom panel, press the UHF knob to select that radio. The knob also allows you to set the reception volume. Now that you have the UHF radio selected, press the / key to use the DCS communications menu. The top of the menu states which radio we are using, UHF AM. Now select F5, ATC. F1, Inches Air Base. F3, Request Startup. Press spacebar to continue once ATC has given you clearance to startup. Press F12 to clear the DCS communications menu. The engine can be started either on the aircraft battery or using an external power source. In both cases, the battery and generator switches should be at their on position, which we have already done. Fuel booster pump switch, POMP. Set to on, March A. The pump should be heard operating, but the rain noise is masking it. Start timer on the clock. Wait for 20 seconds, to allow the fuel pump enough time to prime the fuel lines. Set the engine starter switch, DMAR, to its run position, up. The green light, start, illuminates, to signal that the engine starter generator is now running. The yellow light, RLT, illuminates, as the electric fuel cock opens. The tachometer indicator pointer starts to register. The T4 engine temperature indicator rises. Above 18,000 RPM, the green start light goes out, indicating that the engine starter generator has disconnected. The generator is now online, indicated by the gene warning light going out. Jet engine RPM continues to rise and stabilizes at an idling speed of 25,000 RPM ± 400. The torque indicator should read 0. Check the T4 turbine temperature, it should decrease once above 35,000 RPM. Set flight controls to neutral, and then gradually move the fuel flow control lever forward, up to the point where the rotor just begins to rotate. You can move the lever by dragging it with the mouse, or by pressing the page up key. At that point, engine RPM should be around 29,000, Don't push the lever forward too quickly, as it can drown the engine. Gradually increase the fuel flow lever, until the RPM of the engine and the rotor synchronize on the RPM gauge. As the RPM increases, the HBTP low gearbox oil pressure warning light goes out. Check that the HMOT, turbine low oil pressure warning light also extinguishes. Check the T4 turbine temperature, it should decrease once above 35,000 RPM. Once the fuel flow lever is fully forward, the engine speed increases and stabilizes at 42,500 RPM, plus minus 400. The red alarm light goes out, to denote that the fuel flow lever is now on its normal flight position. The engine and rotor are now at their proper operational speed. Press spacebar to continue. Pitot heat switch. Set it to on, to prevent icing on the pitot probe. Trim actuator switch. Set to on. The trim actuator allows fine trimming, it is set with the pilot cyclic China hat. It allows the pilot to finely set the aircraft attitude, and it may be used complementary with the magnetic brake system. Engine sand filter switch. Set to on when sandy conditions are expected, as it is for this flight. Its green light above will illuminate when active. Check voltmeter. This check is to confirm that the generator is working correctly. The previous check was on battery power. Its needle should be on the green. Warning panel. All its lights should be out, except PA as the autopilot is not enabled yet. Windshield wipers. As it is raining, enable both pilot and co-pilot's wipers. Their switches have 3 positions, up for slow, middle for off, and down for fast. Set both as desired. Gyroscopic platform mode. Turn the knob to its GM position. The gyroscopic platform will take around 1 minute to warm up. The gyroscope visor will show a red-white barber pole flag, changing to on once it is finished. Don't wait for its warm-up, press spacebar to continue with the checklist. Nadir navigation unit. Set its mode knob to standby, VAY, it will begin its alignment phase which takes 70 seconds. The nadir will display error, air, and nav cautions while aligning. They will extinguish once it is aligned. Don't wait for its alignment, press spacebar to continue with the checklist. Radar altimeter switch. Set to on by turning its knob with the mouse wheel to its M position. Test the altimeter by click and hold the knob, a stripped flag will appear and the needle will indicate 7 meters. Set the low altitude index by rotating the highlighted knob. The knob's red light will illuminate when the helicopter is below the index's altitude. For this training, set it to 20 meters. Main ADI, Attitude Director Indicator. Uncage, by click and hold its knob until the ball gets centered and stops moving, then release the knob. Select the navigation source for the white bars of the ADI. To link them to the nadir system, set the knob to the DOP position. Standby ADI. Uncage, by left-clicking on its caging knob, holding it and scrolling your mouse wheel to remove the flag. Once uncaged, press spacebar to continue with the cold start. Confirm that the gyroscopic platform has warmed up, as the autopilot requires it to function. The gyroscope visor should show on if it is ready. Autopilot pitch, roll and yaw channels. Set to on by clicking them to the up position. Autopilot power switch. Set to on, the AP channels should be previously on, or this switch won't hold. The autopilot and flight stabilization system is now active. The pitch, roll, and your indicators should move into their neutral positions, and the PA warning light should go out. Confirm that the nadir navigation has finished alignment. On its display the error, air, and nav cautions should have extinguished. Nadir mode knob. Set to ground. If the waypoint preload option has been selected in the mission editor, all your waypoints will be entered already in the nadir waypoint database. If not, you would have to enter each waypoint coordinates manually. Nadir parameter knob. Set to its BUT position, then you can use its keypad to select waypoints. Your current flight plan includes 4 waypoints. You can press the keys 1 through 4 to visualize their coordinates. Radar warning receiver Drax 33. Set to on, by moving the highlighted switch to its center position. The RWR will take around 3 minutes to warm up, afterwards it will illuminate its display. Flare dispenser power switch. Set to either slow, LE, or fast, VE. AR turns the dispenser power off. Flare dispenser launch quantity. Set to either CC, single, or SEC, continuous sequence. Flare dispenser switch cover. Up, to leave it ready for action. IFF power switch. Set to on. Identification friend or foe, IFF, is a device that allows other aircrafts of our same coalition to recognize us as friendly and thus they won't attack us. Currently the Gazelle has a limited functionality IFF, so for the moment we will just power it on and will not set the code passwords that the system uses. We have already turned on the UHF radio on a prior procedure step, let's now turn on the remaining communication radios. VHF AM radio. First, perform the unit's test, by setting its mode ring to its test position. Good, an audio tone should be heard. Now set the mode back to M, March A, or SIL, the latter enables a squelch to filter out the static noise. As a test, let's use the 2 highlighted knobs to tune the ATC frequency for VHF, 118.45 MHz. Good, now select the VHF radio on the intercom panel. Now that you have the VHF radio selected, press the / key to use the DCS communications menu. The top of the menu states which radio we are using, VHF AM. Now select F2, request hover check. Press spacebar to continue, once ATC has answered.
Springfield 1-1, cleared for hover check.
FMPR 4G radio. Turn it on by setting its mode knob to traffic. This radio is used for radio encrypted communications in NATO operations and, as it is still highly classified, its simulated use in DCS is very basic. As a test, select its preset channel number 2, which is set to 32 MHz, for a local radio station. Good, you should now be hearing the station's music. Congratulations, you have completed a full cold start procedure of the Gazelle SA-342, including checks and alignment. Well done. Press spacebar to exit from the mission.